Good afternoon, everyone. May I invite you to take a seat so we can get started? Thank you. All right. Good afternoon, everyone, and big warm welcome to you all, including colleagues who are watching this event on the live stream. This is really a wonderful occasion. I'm so pleased to join all of you. And also, it's my great honor to introduce Jack Dangermond. I don't think truly Jack requires any introduction, but let me just indulge myself and share a few thoughts. First, I got to know Jack, even though I only met him in person half an hour ago, but I know he is, as some person have called him, the godfather of the digital maps. Without us knowing it, I think Jack has been determining our lives in many ways. Just this morning, I received a package from my sister delivered by UPS. And we all know that UPS has been using Esri's maps to optimize their routing for delivery, which has saved them an estimated $300 million a year. Just 2 days ago, I went to my neighborhood Walgreens to get medicine for the cat we rescued. And I also learned that Walgreens has been using Esri's product to help them decide where the new shops should be located, and also for their sales staff to track their sales and monitor, for example, flus, and also to determine how to up their stocks. So there are really so many ways that Esri's product has been helping us. As I understand, this is also an outdated estimate. By 3 years ago, Esri's product is already being used by over 350,000 organizations, which help to generate 150 million maps a day. Even World Bank is a strong partner with Esri. Last year, I had the honor personally to sign an MOU with Esri to allowing our CAPI-based survey solutions to integrate Esri's geospatial applications SDK, which allowed countries to conduct surveys and censuses with such higher resolution and allowing us to use the data collected in many new ways that we could not imagine years ago. Second, I also learned Jack is a visionary inventor. Maybe I should say a reinventor, given that over the past 50 years, you have led Esri to really adapt to the waves after waves of changes in computing technology and adapting and developing new products to meet new needs. I'm really glad to have heard Bill Gates talking about how they have been using Esri to help them launch their campaigns against malaria and Ebola. And these are the words Bill Gates had. One of the area of technology that have gone further than I ever expected is mapping. We have Jack Dangermond to thank, in large part for his pioneering effort of almost 50 years. He's one of a kind. Really, I think from a small consulting firm to have grown Esri over the past 50 years to $1 billion company with over 3,500 employees and almost half of the industry market share, Jack really have led Esri to transform itself and offered the world what we have today. Third, Jack is a giver. We all know that over the years, Esri has shared their product free of charge to many NGOs and also donated more than $1 billion worth of software to schools in the US, Africa, and Europe. And just in 2016, Jack and his wife Laura, who is the co-founder of Esri, made the giving pledge And just a year ago, the couple has made a gift of over 160 million to help the Nature Conservancy to preserve and further develop a special trench of land in California. It's really a gift to the world from this remarkable couple. So it's really wonderful for us to have this honor to have Jack to speak with us at this conference about catalyzing innovation. We all know that geospatial technology and its applications are transforming how we conduct our lives daily. And it helps us to respond to natural disasters on an urgent basis. But more importantly, it offers huge potential for us to address chronic crises, such as extreme poverty, through means such as secured land tenure. So it's my great pleasure to invite Jack to give us his keynote, and we will welcome you to raise your questions and have a dialogue with Jack afterwards.
Thank you. Thank you, Hoshan. Thank you very much. Appreciate it. Well, good afternoon, ladies and gentlemen. It's my great pleasure to meet you for the first time, many of you for the first time. My background was in training as a landscape architect and urban planner. And as a young graduate student, I became familiar with computer mapping and computers in general, and I just fell in love with it. I don't have any other way to explain it. I really liked the idea that I could use digital geography as a way to build rational ways of thinking about land use planning and environmental conservation. When I left Harvard, I was in a wonderful lab there. I went back to California to where my parents lived and started this little organization called Environmental Systems Research Institute. And at that time, it was a nonprofit, and we focused on doing project work, environmental work and planning work, using computerized tools. And I thought that was going to be my life. But after about 10 years of doing this, people wanted to get their hands on our software that we were building, and we were distributing at that time as open source tools. And our users got together and they said, would you please turn these tools into a product? And without really knowing what I was doing, I said, oh, sure, yeah, I'll do that. So then we began to move from being a company that was working on real projects to a software company. And that just sort of changed my life. I became focused on, instead of applying digital geography to problems like land use planning, I became a tool builder that would build tools that would help other people do their work better using digital geography. So you understand what I'm talking about? Sometimes in your life things change, and for me that was a big change, and one that ultimately led to Esri as we know it today. The purpose of this conference is to look at technology, land information systems, all of these topics, securing land tenure, catalyzing innovation. These are all questions that you've sent to me and said, this is what I really want you to talk about. And I will touch on some of those. But in addition, on the right side, I really think that the purpose of this meeting is all about sharing and learning and building new relationships and collaboration. This is, for me, always the objective of meetings like this, is to build friendship. And so in this room and in the virtual room that we're in, there are lots of different interests, different kinds of backgrounds, different disciplines from the academy, from government, from the private sector. And you have these few things in common, the theme of this conference. And what I want to do is talk specifically about geospatial infrastructure. And I'll try to define that, show some examples of it, and show generally where the technology is going. But going back to the agenda, I'd like you to all stand up and introduce yourself to somebody new and tell them why you're here so we can get to know each other a little bit more comfortably. Could you do that for me now, please? Okay, good. Thank you. That's good, thanks. Thank you very much. Thank you very much. Perfect. Thanks very much. Good, thanks. That's good. Thanks. Well, that's good. Okay, you can sit down now. Thank you. Good. So while I'm going to share some data, wasn't that fun? I mean, just getting to know each other more. Because it's actually through personal relationships that we learn most about things like we're talking about in these subject lists. So I want that to go on, continue going on during the rest of the week while you're here. I'd also like to kick off my talk with sharing what other people, some of you actually here in the room and others, are doing with this technology of geospatial GIS mapping. And it covers virtually every issue that we are being challenged with at a global scale today. It starts with things like natural resource management, forests, water, agricultural management, mining, from searches in Mongolia to searches in Texas for the right kind of minerals and resources. Many GIS and geospatial users are managing our environment. That's a lot to say. At least they're measuring it. They're looking at everything from detailed water quality in the lower right with field measurement to synoptic measurement of the whole planet, looking at things like disease risk, invasive species, habitat corridor mapping using geospatial analytics. And, of course, the core subject of this conference, managing and analyzing or applying land information, parcels, registries, and the like. Not only mapping of parcels, but linking it to registry information and making maps and interpretive models that help us in valuation and understanding. Understanding, in many ways, precedes action. And this technology is also opening up with viewers to allow the public to engage with their government, seeing what couldn't be seen before, but now through the web and mapping is enabling it. Many users in this field are preparing for and responding to big disasters, and we're seeing this more as climate changes. Big disasters, hurricanes, floods, short-term disasters, and things like sea level rise, which is gradually becoming a disaster for our shorelines. People use geospatial technology to see things like demographic patterns, things like the SDG patterns, see diseases, see patterns, relationships, combinations of geographic distribution. The map in the lower right here simply showing how in West Africa, Ebola was put into a box by taking the geographic approach and shutting it down. In urban development and redevelopment, GIS is foundational. It's building on land information systems for things like new town planning, like outside of Abu Dhabi, or urban redevelopment, or urban planning, seeing what we can't normally see using digital abstractions. And new technologies like remote sensing and LiDAR are pushing the envelope. This combined with AI and machine learning is allowing us to extract information that we couldn't really get our hands on using traditional methods. On the web, maps are being made by the billions every day. They're telling stories, like all of these maps that I showed reflect stories about change, stories about fire, stories about peace agreements, like in Colombia, stories about traffic, or stories about oceans and their currents and things that are occurring. Digital geography, everything I've been talking about, is also opening up new connections with citizens. It's allowing our governments to become more transparent and connected. This is ranging from everything from the SDG data at the UN scale all the way down to little towns who are saying, I want people to understand what we're planning in our town and give me feedback, kind of crowdsourcing of reaction. And these are magnificent things. This is all going on by the thousands and thousands of organizations around the world who have taken within their organization geospatial and made it real to help them do their work better. The second thing I want to talk about is a broader vision. And this is a vision, it's just Jack's little vision, but I somehow think that this is the consensus of what a lot of us are feeling. That is that geospatial information can actually transform and deal with many of the issues that we're facing on the planet today. Let me build a case. You and I live in a complex world. We know this. We read the papers, we watch television. We see that it's interconnected. What happens here in the way of policies creates a reaction there. What happens in one scientific field or one agency organization changes major things in another. And we use geography, the science of our world, as a way to organize and understand human patterns and also natural patterns. These are kind of changing and interrelated, like your body. And these patterns are constantly changing. Population is growing, land use is expanding, and so on. Now, within most of your lifetimes, we've seen this pace of change accelerate. And this is driven in part by continued population growth, but also the implications of that growth, the human footprint on the planet. And these are creating lots of challenges for us as land managers or managers of our planet. Some would say it's threatening not only our natural world, but even the future of the world as we know it as human beings. Clearly, the evidence is here. We hear about the evidence, we see the evidence, and some say this, that we're in a place that no human beings have ever been before. This is challenging when we think about a huge organization like the bank and its leadership. It's huge responsibility for particularly you in this room, who are the organizers of land information and resource information systems. We need to have better understanding on our planet. And at a contextual level, this is what is always talking to me in the back of my head. We need more understanding. We also need more collaboration, and we also need action. So, what should we do? What should we, as just little individuals or organizations, do? And there's lots of things going on, lots of good work going on around the planet. But for me, the role of digital geography, the role of what people can do with geospatial infrastructure is my life. It's where I focus. And it allows us to envision things like a planner would do geographically. It allows us to transform land information. That's one of the big topics I want to talk about. But also that, in turn, helps us organize a more sustainable urban footprint and allows us to engage people. The evidence that I just showed you with these examples make it clear that we can protect biodiversity, we can design with nature, we can make things more efficient, like the UPS delivery trucks, all kinds of interesting things we can do. And to do this, we need to stay current with the rapidly changing technology. This is part of the reason why this conference is here, is to learn and build relationships from each other that teach us and allow us to grow. So am I going too slow? Should I go faster? Or is this okay? I need your feedback. It's okay? Faster or slower? Okay, this is faster, slower. Okay, faster. Okay, how many say faster? Okay, the 7 of you leave the room. Okay, I'll try to go faster. Look, the way I like to organize this is something I'm calling the science of where. This is a simple way to describe geospatial infrastructure. It starts by measuring geographic data measurement and map making, and then moving from there into analytics, and moving from there into decision support, and moving from there into action. So I want you to look at this diagram and see where you fit. What part of that diagram does your organization actually own? Is it in data creation, or making maps, or is it doing models of valuation? Is it providing a basis for planners? Are you planners? Or do you actually do action work? This is important to set the tone for what I'm going to go into next. I call that center stuff geospatial infrastructure. Some people like to refer to it as spatial data infrastructure, or some people like to refer to it as a GIS, or some people like to refer to it as maps and data. I don't care. It's basically, today, a kind of cloud-based geospatial information system. So what is it? What I'm going to describe to you is GIS at scale. And this really means content, the organization of content, the ability to leverage content with mapping and analytic tools, and leveraging location, the idea of integrating information. Overlaying maps is a simple way to describe it. It's a platform for sharing, this geospatial platform for sharing and collaboration, and also for solving problems, like many of those examples I showed. Agricultural problems, water problems, climate problems. It's a platform or an infrastructure. This infrastructure is advancing really rapidly. It's driven by data and new innovation in computing and in geospatial innovation itself. And ladies and gentlemen, right about now, what's occurring is a new pattern is emerging. I mean, I'm kind of an old guy here, probably the oldest in the room. When I first started working, it was mainframe computers. That was it. And then it went to mini computers. And then it went to workstation computers. And then it went to desktop computers. And then it went to servers. And then it went to web. This evolution over these last 5 decades of computing has been incredible. and it's accelerating. Now what the new pattern is web services based, much easier to use, much more flexible, much more open patterns. That's what I'm going to talk about. And this is being driven by new kinds of data, new kinds of remote sensing or field measurement, IoT, real time. It's also being driven by new patterns of computing, smaller machines, faster machines, more connected machines, smarter machines, the integration of AI and machine learning machines, and characterized by SaaS, software as a service solutions, instead of buying your own infrastructure. And that's accelerating. This is only 2019. So think about what's happened in the last 5 or 10 or 20 years and what's about to happen. And also in that space, lots of new innovation in geospatial, new tools for visualization, or smart mapping, or smart devices, or connected with people in the field, becoming more pervasive. That pattern, like I said, is easier and becoming more pervasive. This pattern I refer to as a web GIS pattern, and it's basically helping everybody do their work. It isn't just for enterprise, it isn't just for the rich, it isn't for the developed countries. This is one of those unifying things, because it's built on the web with web services, that can democratize the concepts of GIS to everyone. It also involves sharing, just like I asked you to get up and share who you were. This is about sharing data. It's building collaborative infrastructure. And it's also about distributed computing. This pattern doesn't say, put it all into the mainframe data bank, or put it all into an Oracle DBMS. No, it's a distributed, networked system, much like the web. And that pattern supports lots of different configurations. It can support an individual doing a project, like when I was young, doing little work. It supports the pattern of building an information system, like a land information system or a cadastre system, or a forestry system or a water system. But what's emerging is a new kind of system. This is a system of systems. This really links all of the existing systems together, kind of like the web itself. I like to call that geospatial infrastructure. I've said that now 4 times. I'll say it at least 3 more times, just so you understand it. And this platform is open. It adheres to standards. It's standards-based. Our standards organizations like OGC and ISO are integral in making this kind of thing work. It's scalable, so you can start small and scale it up to something big. And it's interoperable with other kinds of systems, like GIS and registry systems, or GIS and financial systems, etc. You with me still? Okay, let me take a vote. Now, faster or slower? Faster? You're going out, man. You're out of the room. I'll see you later. All right. Question is, what makes this WebGIS, which is, by the way, just growing like fire, so compelling? It's not one thing, but first I'll simply say it's much easier to use. So this is a big one, and it's interconnected. It uses web maps and web apps to access it and communicate. I'll talk about the definition of these in a moment. It uses smarts and machine learning integrated into the platform. It uses portals to organize the connections. It uses field apps or sophisticated desktop apps. It spans the whole gamut. It isn't just one thing. And they're fueled by content, rich content and powerful tools, providing this foundation for a geospatial infrastructure. And if you think about other infrastructures, we have highway infrastructures, we have connectivity network infrastructure. So I want you to get in the spirit that this is not just a few little systems. This is building a ubiquitous thing called infrastructure that applications can live on top of. A country can build their geospatial infrastructure and then leverage it. They can leverage their geospatial infrastructure, all their investments in content and so forth, to do startups in the slums of Nairobi. People can be innovative because they can just go there and start building cool apps and sell them to Sweden or sell them to Japan or whatever. This is kind of an opening up platform that governments can support, but public and private partners can abound inside of. This platform means I can integrate all types of data through a technique of abstraction and services. I can read in imagery and tabular and maps and 3D and real-time and BIMs and LiDAR data into one dynamically normalized environment that's accessible through portals. And this can be distributed. And it's services-based. Unlike its predecessor, where we had to put everything into one data bank, this means I can have distributed services that can be dynamically integrated. That's a big concept. And maps are the way that those data sets show up. And those maps, which are abstractions of the basic data, can be emailed around. I can send you a map, a one map concept, on parcels or on forests or on fire or on water or whatever. It's a new kind of language. Much like the Google map unified the world in terms of seeing where we were and routing, this generation of technology abstracts the data in the same way, except that it's all the rich enterprise data that agencies build. And complementing maps are apps. Apps make the maps come alive. Field apps, dashboard apps, design apps, reporting apps, story map apps. So you see how this works like a big hourglass. I pull all the different distributed heterogeneous data together, whatever the semantics is, abstract it and put it out, no matter whether it's an iPhone or an Android phone or a browser or a thick client, doesn't matter, because it's normalized dynamically. We could not do that without fast computing and thick networks. Just not possible before. And these apps are taking the science, the geographic knowledge everywhere, to people, citizens, to dashboards in executive boardrooms, everywhere. They're supporting science, they're supporting engagement, they're supporting innovation. And those apps include GIS integration from earth science measurements. So earth science together with AI, together with big spatial modeling, are doing things like up in the upper left. This is a model that's built by the U.S. NOAA Weather Service and our U.S. Geological Survey. It takes raindrops, which are forecasted in the future, and drops them onto the land 15 days in advance, and then runs the raindrops through the hydrological network and predicts 15 days in advance where the floods are going to be. So we all are used to getting a 15-day forecast or 5-day forecast. Is it raining outside yet or not? I'm not sure. And, there's all the old jokes that you do believe the weatherman or not. But look, this model shows for people in the way of floods what can happen. And this is just an example of geospatial infrastructure looking into the future. Others are doing it for 10 years or even 100 years using the IPCC climate change models, who have similar kinds of visualizations. Where is it going to get hot? Where will we be able to grow coffee in the future? Where will we be able to deal with loss of biodiversity in the future? All those things, we're learning how to use the platform to make the forecasts for. And these all have implications for government. They have implications for the private sector. They have implications for you as individuals. Do I live near the river that's going to flood or not? Do I want to live in Singapore or Indonesia where it's going to get very warm over the next 50 years? What must I do? So these all will signal for us future behavior. Now this WebGIS does this in an interesting way. It abstracts the data, but it also organizes the data. It organizes in catalogs data services, traditional like Google search catalogs. It also organizes applications and models, so I can search and find a model for this or content for that. It also organizes the outputs of systems, like I make a beautiful map and I want to share it, so I want to register it so other people can find it. It organizes also people, like I'm Jack. I have privileges to look at certain data and not other data. And it organizes groups, just like social media, like Facebook or whatever. I will share my data or I won't. So all the different aspects of geospatial infrastructure can now be managed. You get the idea? This is a small little building block in the story that I'm trying to tell. So I'm going slow, and I apologize for going slow. But these building blocks are important. They're the technology cornerstones that enable it. What does this mean? It means that this is driving a term that many of you now are familiar with, digital transformation. And many think that digital transformation is only in the wealthy countries. And true, it's happening in certain countries faster than others. So far. So far. But as this rolls out across the planet, it's going to flatten out the planet in terms of access. That's my personal view. It means being able to integrate different work, geospatially referenced work, together, discoverable through portals, so that we can see things holistically and in real time. I like to call it simultaneity. Simultaneously, we are doing land registration and the vegetation is changing. Or simultaneously, we're doing this work, and we can integrate them using location or geography as a common platform. This is why, ladies and gentlemen, your work is so very, very important, because it plugs into this. Some of you are, I know, more interested in SDI than in land. The SDI 2.0 is all about exactly this: serverizing, integrating dynamically all the different dimensions of government and society. Well, I was asked to talk in a more focused manner about two things. One is land information. So this web technology, I would say, is not only transforming the world, but it's especially transforming land information, a topic that many of you hold close to yourself. And there's a lot of little innovations. Again, I'll go through these systematically, carefully. One of them is with an integrated platform with solutions that are ready to use. Like I use my iPhone. When I bought this, I didn't buy the disc, and I didn't buy the music, and I didn't buy the screen, I didn't buy the glass separately and engineer these together. No, I simply bought Steve's phone. It now has broken glass on it, so it's kind of old. My wife keeps telling me I need to buy a new one. But it just works. It just works. And that's what's starting to happen as solutions are appearing. And so governments, instead of these long, drawn-out processes, will start buying technology, putting them in place, organizing the workflows, and making them work. That's my bias. Okay, I know it's not perfect, but you know better than I. That's my bias. Anyway, other things that are changing are cloud and web services. These advanced analytics and visualization, they're not for everybody, but they're starting to show up and have big impacts. And also the integrated imagery from spacecraft, ready to use immediately, integrated sensor observational data, ready to use immediately, and the whole IoT world, ready to use immediately. So I can tell some of you sort of blink out on me, and then I know that I've lost your attention, so I'm going to go faster. First, the architecture. The modern GIS, or web GIS pattern, as I call it, is 3 systems in one. One of those systems is the system of record keeping. This is sort of like financial record keeping or registry record keeping. It's all about parcels. I'm transactionally updating my parcels. It's a database. Pretty boring stuff for some people. The second part is a system of insights or analytics. Some people call it BI. Here, it's all about, for example, in land information, valuation. How can I analyze buffers and zones to create the right property assessments? And the third is how do I engage, a system of engagement, engage with people, the citizens, other agencies. That's really all about open data or open services. It's not enough to just have open data. Open data is kind of the booby prize. What do I do with open data? I want to have open services so that I can integrate those services, mash them up with other services, and create information products. The second big innovation that's occurred is the web now offers not a few hundred, but a few million open data sets and services, many of them implemented as ready-to-use services. Today I can go and look at free base maps, topographic base maps for the planet. Well, I could do that with kind of Google in the consumer world, but I'm talking about enterprise stuff. I can look at imagery for the whole planet. Every night I can look at last night's take for Landsat or Sentinel, the European and US satellites. Every hour I can look at the latest OSM street map, and all the new updates on OSM are immediately available to me as a base map for anything I want to do. So that's all changing. Thousands of data sets that are authoritative source that are actually ready to use immediately. That's different than when I was a young person. We had to spend 90% of our money collecting the data and digitizing the data and cleaning it all, and then we could do something. Today, the data is already collected. This isn't just in geospatial field, it's also in science in general. Science is changing. Instead of the traditional scientific experiment where I collect the data and I spend, 60% of my PhD collecting the data, and then I can start to think and do something. No, now I can connect in and leverage what other people have contributed in the way of data and do better science as a result of it. That's happening in the geospatial field. There are also ready-to-use parcel management systems that have apps and workflows out of the box from a variety of different sources. That's different. It's like buying the iPhone, dropping it in place, and then spending the money on data, maybe, or on education to be able to use it. There are also field apps, apps that allow me to go to the field and collect high quality, high resolution, high accuracy observational data around properties. And immediately upon collecting it, it's put into a cloud server that other people can look at and see. They can track my performance. They can even see where I'm at. All that's getting connected. And there's also spatial analytics. Literally thousands of tools that can do analytics on the data that's being collected even in real time. Little data sets or big data sets. Hundreds of thousands of features or billions of features. And we can do raster analysis, integrating with imagery. We can do spatial temporal analytics. And it's open now with Python notebooks, so I can program the applications and turn out really beautiful applications like this. Analytics for valuation modeling, which used exploratory Bayesian kriging, or fancy terms like geographically weighted regression, to figure out, what is so, to correlate my data and make accurate predictions. I can use now machine learning and AI tools right inside of my geospatial workstation and make predictions that we could only dream about in the past. And these are showing up in very practical, real life changing activities. Patterns of property, patterns of poverty, patterns of urbanization, and predicting what's next in land administration systems. And this isn't just in the sophisticated countries, it's happening all over. Imagery has now become a main dimension of GIS. Instead of having an image processing system and a GIS system, or a land registration system and those guys down the hall doing imagery, it's all integrated. So I can bring in multiple sensors, small sat imagery like planet, or heavy digital globe kind of imagery, classify things, do amazing results, and visualize it with my other data. I can do analytics with my other data. I can do map production with the integration of those forces. And 3D, like 2D, has just taken off. Not only 3D visualization, but 3D analytics. For valuation, viewshed is important. So I can now build 3D cities by extruding data or measuring data and drive that right into BIM models for detailed assessments and make it publicly available through simple apps or open data or comparable analysis tools like these. Now, I want to talk about something else, which is app development. As someone who spent a lot of money on apps, I sort of hesitate to tell you this, but have any of you spent money on building apps? Please show me your hands. Don't be shy about this, right? Yeah, these apps, traditionally a web app or a device app, cost $25,000, $50,000, $100,000, doesn't matter. There's a new generation of tools for web app building. These are widgets that allow me to take services and very quickly configure an app in a matter of a couple hours. This is sort of devastating for somebody like me who spent so much money on them, because I can actually now sit down and, as a non-programmer, actually configure an app and have it ready to go in a day. Even in the California fires last fall, the fire chief there said, I want an app for this fire. Can you build that? So we built it in an afternoon, and it was for citizens. And the fire got over, they threw the app away. That's a different kind of logic. Quick. Last year, over 500,000 public apps were built using this web platform. Many of them, think about throwaway apps. I don't think about throwaway phones, but I can think about throwaway apps easily now. And this web GIS framework is open. It's open with open APIs and lots of open source tools and support for standards. This is the new behavior of GIS, integrating with open science toolkits, things like R, TensorFlow, Python notebooks, etc. This is the way it will continue to go. All right. So I've talked a bit about examples. I've talked a bit about the big picture vision. And I've talked about very specific technologies. Three things. There's going to be a test afterwards. But now I want to talk about a fourth thing, which is that WebGIS, this pattern is enabling us to do new kinds of workflows in the land information environment. It allows us to take boundaries and documents and testimony from the field, move it into the cloud, and generate certificates. And there are community-led approaches, I like to call them bottom-up, and there are top-down approaches, like whole countries at a time. The community approaches that I want to pick up here are from a couple of organizations. One of them is Cadastre, which is securing land rights with partners all over the world. Just a few examples here are in Odisha in India, already having done 50,000 parcels, but moving to 13 million parcels. Really powerful methodology and process for informing, assessing what's needed, using the right fit for purpose is the popular jargon, technology, and then going out with partners and building systems. This is not the multi-million-dollar top-down system, it's bottom-up. Another organization called Madim is a private sector operation down in Zambia following the same kind of approach. It's training locals who are collecting informal cadastre, sharing it with chiefs in the village here, and then moving it into a more formal environment, much like Cadastre does. State-led approaches include things like Colombia, EGAC. They're working closely with Cadastre out of Holland and others. Our partners, Trimble, are looking at, again, a combination of some social bottom-up approach, but also with a top-down framework for organizing the information. Similarly, in Kenya, same institutions working together to take both a top-down and a bottom-up. Look, these are not little pilots. These are real systems. I really don't like to do little pilots. They get me nervous. I like to concentrate on doing real stuff that really actually works. This is going on in Mozambique. Same thing. It's going on in Myanmar. Same thing. It's going on in Jamaica. Comprehensive land information. This is a system actually completely implemented. Now they're moving it into 3D cadastre. So these aren't experiments or little grants things. They're right into the fabric of the social institutions building this geospatial infrastructure for the nation. It's being done in Cyprus. Cyprus did it in the 90s. They're redoing it. They did it in the 90s with client-server technology. They're redoing it now with web services, and it's very, very encouraging. All right. I'm going to conclude with one small, short description of things about the SDGs. Your work in land administration is absolutely critical for the civil society in each country. It's also critical for a larger goal of making our planet sustainable. The UN has initiated a federated system using these WebGIS services to have country-owned, country-led nodes in a network that then feed information into the system of systems hierarchy at the UN. Already there's 25 countries in the statistical divisions who have stood up these systems, and there's more coming. These call for local ownership in country of a server and connecting it to the web for local use and also data sharing with the UN. This example basically shows story maps communicating sustainable development goals associated with agriculture. In UAE, they're reporting out maps on things like agriculture production and sustainable agriculture. In Mexico, they're reporting out a whole library of SDG indicators about health. In Ireland, in Tanzania, in UAE, and Senegal, in lots of places, they're standing up their own server for their own country first. And these are are engaging in the country with a larger network of citizen groups or NGOs or the private sector. Those individual countries are sharing their indicators according to the UN standards into a larger federated system. So I'll be able to look at a map for the whole planet eventually of each of the indicators. Now, some of these are definitely bottom-up statistical reporting through the statistical organizations, and land information will come in through that channel. It'll be aggregated and reported. There's similarly top-down sensor environments, like satellites that are going to collect information on forests and vegetation change and urbanization and land use and the footprint, coming from the other direction. So the SDG reporting geospatial infrastructure framework is going to come in with multiple sensors, but it will be a framework that I think helps us all better understand and do comparative analysis. Now, my big thought is this is going to change behavior as we all, meaning all of our societies in each country, come to know what the hell we are doing with the planet. It'll stimulate change. That's the only thing I can believe in, actually. It's my religion, is that we can create understanding and it'll change behavior. Okay, well, I am done with my technical presentation. I'll simply close by saying my organization is all about serving our users. That's, many of you are here in this room. That's what we care about. We started it as a nonprofit. We are no longer a nonprofit, but we are an independent company, and we have held to our main mission of doing work, which is advancing GIS and helping our users do their work better. This is our 50th year. We're very proud of that. We continue to grow, and we have a bunch of things that I want to share with you about this organization. First, we have hundreds of special relationships that have helped us by helping NGOs and helping other special organizations. It's helped us as an organization support you, our users. It's also my privilege to be able to make a series of grants. We have grants in education. We have grants now in land modernization, particularly for the bottom end 100 countries that are impoverished, and also modernization of statistical organizations in that same group. In conservation, we support 11,000 NGOs from the Nature Conservancy at the top end all the way down to little watershed organizations and forestry units. In education, as was mentioned earlier, we have a grant for cloud-based use of our software in any K-12 school on the planet. And we have, from September to December, we had about 3.4 million students who took those classes and learned about, well, it's about building the next generation, the people that will follow you and me, getting them spatially literate, getting them understanding what we must do. And also, we have a series of modernization grants. I've spoke about these already in statistics and in land administration. And our partners here with the World Bank are funding capacity development. We're providing the technology in partnership with them. The last thing I'll mention is something called the Africa Geoportal. Some of you may have heard of this. This envisions thousands of data sets. It actually already includes thousands of data sets for all of Africa, and also a sharing environment so that people doing work can share their data sets and services openly. This has lots of learning resources. There's a marketplace so you can sell and buy locally built products. And the best of all is it's free. It's for our users, of course, but also for everybody else on the continent. Implementing GIS involves much more than technology. I mean, yes, that's about 5% of the deal. That's what I'm all involved in. I love it. but it doesn't make systems work. They require vision and leadership, building the institutional capacity, a champion, often some of you in this room are champions, a clear strategy, a design for the systems. It requires work, really. It requires ongoing governance, like you guys know a lot about that, I suppose. Also, it requires really great people. This is where you come in. People that are willing to collaborate with their colleagues in other departments or in other organizations. And as I said before, collaboration happens at the speed of trust. This is one of my favorite sayings. So being able to trust individuals and agencies in your countries are really going to be one of the most important components. I'll conclude by saying we, you and me, these are interesting times. Interesting is not the word for it. We are in a changing world, and we don't exactly know what's going to come next. At my age, I really don't know. I wish I could tell you what the future will be, but so much is now unknown. And this is creating some significant problems. And these are problems, or you might say challenges. Those of you who are young will say those are challenges. And we need to transform how we understand things. We need to understand how we carry out our work. It can't be the same pattern as the past. Some of my colleagues think we need to cut the planet's population in half. That'll be the answer, one way or the other, because we can't sustain it the way it's going right now. Then people sort of get squirmish about that, or they smile about it. They want to, and then, well, okay, I've got to get back home. But actually, the truth is, we're living in this right now, today. And I still believe, as I believed 50 years ago, that the world of geospatial or GIS or geographic knowledge provides us the best platform to scale, to take it to scale. Not just have a little incident of an activity, but scale it out. This is a term that's very popular at this conference this week, is scaling it up, scaling it out. So that's going to require collaboration, and it'll require a kind of sense of trust. Let's work together on this. And I believe if you do that, then we actually can talk about what's next, a more sustainable and a better world. So thank you, ladies and gentlemen. I'm sorry I spoke too slow, 10 minutes over. The guy who said I was speaking too, he left. So anyway, thank you again very much. Thank you.